Question 1, part 3, we want to find the range if the initial velocity is 21i and 28j. So this is the problem. So this is question 1, part 3. Question 1, part 3. Remember, it's traveling at 21i plus 28j meters per second. If you know that initial velocity, this is ordinary mechanics, so everything is deterministic. If you know the state and position and velocity of something at any one time, you can work out its position and at any other time, and its velocity and acceleration. So the whole thing is deterministic. So that's interesting. That once you know that it starts off at this velocity, traveling up at 28 meters per second and traveling this way at 21. Once we know just that, we can work out exactly where it will be at any time, what direction it will be going in, exactly what its velocity will be, and so on. And so this problem now, we want to find the range. Now the range is the distance horizontally, the maximum distance. So that actually equals the maximum x max. That's what that is, the range. Okay, so there's actually two different ways to do it. I'm going to do it one way, which I'm going to call A. And in this method, we could realize that actually, if we want to find the range that is along here, what we need to find first is the time at which how long it takes to go that far. If we knew how long it takes to get there, and we know it's traveling 21 meters per second all the way, then we just multiply the velocity by the time and we'd get the actual range. But to do that, we'd have to find out what time is it here. So obviously the time is 0 when it gets to here. So the time here is equal to what? That can also often be called the time of flight. So that makes sense. Okay, so if we look at the usual U, V, A, S, and T. Now although we're looking for the time for it to get from there to go the full range, actually the time it takes to go from there up and come back down is also going to be the same time. So the time it would take to go up and down vertically is the same as the time it takes to go from here to here, because it does those two. So basically, if we look at the y directions, even though we're actually looking for range, and we look at these, we can see that, right, so the time here is what we're looking for. We'll call this the time of flight. Okay, the initial velocity going straight up is 28. The final velocity when it comes back down will actually be, I'll just draw this in another, now, will actually be coming down there. It will be minus 28 when it gets to there, funny enough. So that is minus 28, the acceleration minus 9.8. The distance up and down will actually be 0 because it's not distance, it's displacement. So the displacement would be 0. So if we look at that and we ask ourselves, okay, we want an equation that has a t in it. So I suppose V equals U plus AT would be the easiest one. It's usually the easiest equation to use. So I'm just going to use that in this case. So V is minus 28 equals 28 minus 9.8 t, which is what we're looking for. Okay, so that's minus 28 and minus another 28 is minus 56 divided by minus 9.8 is actually the time of flight. Okay, so that's one way to do it. So that is minus the time of flight minus 58 minus 9.8 works out to be the so 58 divided by 9.8 works out at 5.7. So 5.7 seconds, okay? So it would take 5.7 seconds to get to there. So that t there is actually equal to 5.7 seconds. Oops. Okay, so that's 5.7 seconds is the time will be here. So if it goes for 5.7 seconds, that means that the distance traveled, the distance in the y, or the maximum range, is going to be the velocity multiplied by the time equals the velocity of 21 multiplied by 5.7. So S max in the x direction equals 21 times 5.7, which is 21 times 5.7 works out at 114, I guess. Okay, 114 meters. That's interesting. Right, so that's one way to do it. So 21 by 5.7 is 114. Okay, if you did it another way, which is where you say to yourself, okay, well, what is the time? You could say what happens at the end is that the distance vertically traveled is the displacement is 0. So if the displacement is 0, so if we do the same u, v, a, s, and t, and these are y, y, y. Okay, and the time. Now the time again is what we're looking for. So the initial velocity is 28 up. Find the velocity, yeah, it's minus 28. The acceleration is minus 9.8, and the distance traveled would be 0 again. Now you could use a different equation for that one. You could actually use the find t by saying s equals ut plus a half a t squared. And then put the numbers in for that, and we can find t this way. This way we wouldn't have to worry about the v, the final velocity. So s is 0, u is 28t minus, plus a half of minus 9.8, and call that t squared. Right, so if I tidy this equation up, I get minus 4.9 t squared minus 28t equals 0. So that means that it's clearly this is a quadratic equation, and the general form of a quadratic equation is ax squared plus bx plus c equals 0. So comparing these two equations together, you can see that that must be a, and this must be b, and c is 0. All right. So that shows us that a is equal to minus 4.9, b is equal to minus 28, and c must be 0 because there's no c term. So we use the minus b formula. So if we realize that minus b plus or minus the square root of b squared minus 4ac all over 2a. That's what t is going to equal in that equation. We solve this equation here. Okay, so filling in those numbers, I see that t must equal, well, minus b is minus 28, so that actually becomes 28 plus or minus, when we say plus, now the square root of b squared, so b squared is minus 28 squared, and get the square of that, you get 28 again. So it's b squared, so that's just 28. And this term here, of course, has a 0 in it, because c is 0, so that would disappear. And we divide all of that by 2 times a, that's 2 times minus 4.9. This should be a plus, of course. That should be positive. That should be positive. And this should be positive, yeah. Because I had minus minus half that. When I bring it to this side of the equation, it becomes a positive. So that's fine. So now that's equal to just 56 divided by 9.8. And 56 divided by 9.8 is actually 5.7 seconds. Okay, now the other, that's one answer. But remember, it's plus or minus. So we just took the plus one. So if we look at the other one, equals 28, it will be minus 28 divided by 9.8, which equals 0. And that makes sense because when the distance in the y direction is 0, it's at 2 points. It's 0 at the beginning when time is 0, and it's here, it's 0 at 5.7 seconds. So now we get 5.7 seconds, same as we had before. So our 5.7 seconds is the same as this. So we did the same thing and we would get the same distance. So there's two different ways to do the same problem.